Alright, this next topic we're going to be multiplying polynomials. So we just got done adding and subtracting. This section 12.6 will be multiplying. There are some key ideas here, just like we had in the last section. And there's similar key ideas, but we're going to apply them in a slightly different way. So the first key idea, is going to be, again, the distributive property. So the distributive property is going to be used in nearly every one of these examples because a polynomial has a bunch of terms in it and we're multiplying them together. So when you multiply with a sum or a difference, you distribute into that sum or difference. So distributive property is going to be key. The second thing is going to be your product rule for exponents. Okay, the product rule for exponents. And this is going to be important because particularly when we multiply things that have the same base, usually variable, same base but different powers, like x to the third times x to the second, you add those powers up and get x to the fifth. Okay, so that's the product rule for exponents. The distributive property, I should probably write this in, is something like a times b plus c equals ab plus ac. The a distributes in to both of those terms. Okay, so these are two important properties. The third thing is to, again, just like before, combine like terms. Okay, so we're going to need to combine like terms at the end. Alright, so let's take a look at how this works with some examples. Let's take a simple one. If I have a monomial times a binomial, something like 7x squared times 2x minus 5. Okay, I've got a monomial on the left multiplied by a binomial on the right. And we're going to distribute, we're going to use the distributive property, just like here. We're going to take the monomial that's on the outside and distribute it in to each term of the binomial. Okay? And distributive property in this case, 7 times 2 is 14, so we multiply the constant or the coefficients together, and then x squared times x. This is where our product rule comes in, where we add the powers together. So x squared, x to the 1, 2 and 1 make 3. So this is x to the third. Keep our minus sign, and then 7 times 5 is 35. And then we keep our x squared in there as well. Okay. So this polynomial on the right is the final product. Alright, so we can continue to build this up and make this a little more complicated. Let's take a look at something like negative 2x times 5x squared minus 3x plus 1. Alright, so again here we're going to need to distribute. Remember, distributive property works no matter how many terms are in the parentheses. So here I'm going to distribute to all three of those terms. Negative 2 times 5 is, am I going to run out of room? That's a question. Before I do that, here, let's move that over. Okay, negative 2 times 5 is negative 10. X times x squared is x to the third. Again, you're adding the powers together. Negative 2 times negative 3 is plus 6. X and x are going to make x squared. Again, adding the powers 1 and 1. Then negative 2 times 1 is negative 2, and the x just hangs out also because that's multiplying by the 1. Right? And so here's our final product. Good. Now, let's make this a little bit more complicated. Instead of a monomial times a binomial or trinomial, let's take two binomials together. I'm going to leave a little more space here for this one. Let's do x plus 3 and 2x minus 5. Now I'm going to treat this binomial on the left just like I did the monomials before, and I'm going to distribute it into the parentheses on the right. I'm going to distribute this whole thing. And so when I do that, I get this whole thing times 2x. I'm going to just call it 2x times x plus 3. And then I'm going to have this whole thing times the negative 5. I'm going to call it minus 5 times x plus 3. Okay, so I've distributed it to both terms on the right. Then I can apply a second and third distributive properties. The 2x can distribute in, and the minus 5 can distribute in. And when I complete those two distributive properties, 2x times x is 2x squared. 2x times 3 is 6x. Minus 5 times x is minus 5x. And minus 5 times 3 is minus 15. And then I combine the like terms. Right? So 2x squared plus 6 minus 5 is plus 1. And then a minus 15 at the end. What I want you to see is how these combinations show up. In fact, if you were to look at the original two polynomials, you can actually jump from the top to, let's see, we can make a jump all the way down here. If we know what combinations to make to get there. And so what I want you to see is that this first term, 2x squared, is the product of x and 2x, the first two terms. 6x was the product of 2 times 3. That's the two inner terms, the ones in the middle. The minus 5x is the product of minus 5 and 3. No, I'm sorry, minus 5 and x. That's the last, wait a minute. No, sorry. Minus 5 and x. Those are the outer two terms. And then the minus 15 comes from the 3 and the minus 5. Those are the last two terms. Okay. So what we have is an acronym, and some people will talk about this, some people don't. I don't really care for it because it doesn't generalize to larger terms here, but or larger polynomials, but we can talk about it. It's called the FOIL method. And so when you look at these combinations, if you take the first terms from each polynomial and multiply them, you get one of these terms. The O is for the outer two terms. Okay, that gives us this one over here. The I is for the two in the middle, the inner two terms. That gives us a 6x. And the L is for the last two terms. Okay, and that gives us a minus 15. I like to think of it this way instead. Okay, well, I like to just say every term on the left has to multiply every term on the right. So the x hits both of those terms, and the 3 hits both of those terms. Okay, so just so you can see this, it's the first, outer, inner, and last, if you want to spell that out. But I would say this general rule: every term on the left must multiply every term on the right. So it doesn't really matter what order. Oh, you can't see that. Every term on the left must multiply every term on the right. So it doesn't matter the order they're in. It doesn't have to be the first, outer, inner, last. You could scramble those and it won't matter. As long as every term on the left multiplies every term on the right. The x hits them both, the 3 hits them both. Okay. All right, in the next video we'll try a few more examples just to get that property down. But it looks really cool when you start getting more terms in each of these polynomials. Then this FOIL method won't quite work, and we're better off looking at this general rule.